Review 15 questions, 45 points. Good. All right, let me start this off. I am very nervous for you guys on Monday. Okay, nervous. Not because of who you are, you're strong students. Not because this test is difficult, because I don't think it is. It's because of Thanksgiving break. That's why I'm nervous. What is fresh in your minds right now is everything we've done this week, which includes the licorice activity we did and indirect proofs. Everything before Thanksgiving break, oh boy, out of sight, out of mind, and that's a big part of the test. So I'm going to do a little review. I'm going to do the review differently today. Usually it's like, all right, here's what's on the test. Any questions? No, go ahead, go to work. So today what I'm going to do, I'm still going to show you what's on the test, give you a few examples, and then we're going to go to the packet and the textbook to do some questions that we might have known to do before break. Okay, because I'm really nervous that stuff before break is really out of sight, out of mind, and that may hurt you on Monday. So I want to give you a little wake-up call today. So let's go. I already told you one indirect proof. Vocab, orthocenter, incenter, centroid, median, altitude. That's all going to be used using a fill in the blank. So for example, the angle bisectors of a triangle all intersect at a point called the blank. And you'll have to fill that in on your own. Down at the bottom, there will be a word bank of all our vocab terms. But the problem is, there's like 6 questions, fill in the blank, and probably 10 vocab words. So it can't be like, oh, I use that one, oh, I got to use that one now. Okay, some of those words in the word bank will not be used. Let's go over number 3 right now. What do I mean by the 3 triangle inequality theorems? The first 2 we did before Thanksgiving break. First one was this, help me out. If you know an angle is exterior, you know it is greater than, I didn't mean to put angle 2. Okay, so the first thing I need from somebody is name 2 angles in that diagram. Angle 1 is bigger than. Okay, angle 1 is bigger than by this theorem. Go in here, give me both angles here, Gianna, both angles. Angle 3 and 4. You cannot say anything about the one next to it, right? So that was the first one we did before Thanksgiving break, which is called the triangle inequality theorem. Exterior angle bigger than either of the 2 remotes. Second one we went over right before break was, hey, if I have a triangle, you can locate the biggest side in the biggest angle, or the biggest side in the smallest side, because it'll be across from 30, 80, 70. Biggest side is always where? Biggest side across from biggest angle, right? So here's my biggest side. And here's my smallest side. Now, we are in honors, so it is not going to be this easy, which leads me to number 4. You'll have to use this theorem on a diagram where I put 2 triangles together. So if you look at, in your packet, if you look at page 39, number 2 and 3 right now, go to the review, page 39. We're going to do one of them in a second, but if you look at page 39, numbers 2 and 3, that's what I'm talking about. 2 triangles together, rank the sides from smallest to largest. Okay, using this theorem. Yes,
All of them?
All the sides, correct. It will be all the sides. And we're about to do that in a minute after I'm done talking here. So those are 2 out of the 3 triangle inequalities. What's the other triangle inequality? That's your licorice activity, which says if you form a triangle, what do you got to know about the 2 sides? 2 sides added up have to be? Greater than the third. Okay? Add up 2 sides, it's got to be greater than the third side. We okay on the 3 inequality theorems, what I'm talking about. Partitions, that's a big part of it. Real quick, 2 vocab words that may come up, and I have pictures of them here. Inscribed polygon versus a circumscribed one. In this diagram right here, which one's the inscribed one? The circle is inscribed. And the triangle is circumscribed. And let me go a little bit deeper with you guys here. Since the circle is inscribed, the center is the inscribed, the center is the in center. All right, that's the in center. It's the center of a circle you can inscribe into a figure. All right. Good there? I just want to make sure we go over what's the difference between circumscribe and inscribe, because you will see that those words come up. And then finally, what do I mean by centroid algebra? That's your 2-to-1 rule. Okay, that's your 2-to-1 rule. One piece is double the other. I threw a lot here, but I want to break it down even more for you. I break this test up into 4 sections. 4 sections on this test that you have to master. First one is all your vocab. Okay, just like the quiz. Do you know all your vocab? Second section, do you know how to do a partition question? Okay, do you know your partitions? I'll have graph paper, graph it, and check it. Third part, that's your inequality theorems that we just went over, the 3 of them. And then the fourth and final part you need to master are what we spent the last 2 days doing, indirect proof. Okay, so that's how I break down this test. Okay, that's how I break it down. Do you know your vocab? Can you do a partition question? Do you understand these 3 theorems? And can you do an indirect proof? Anything you want to ask before we go into some problems? Anything? You ready to go? Sorry, Sully, go ahead.
Are we going to have to do a construction?
No, good, thank you. No constructions. I already did that on the quiz. I'm done. Okay, no constructions. Ready to go? Okay, I'm going to start in your packet with page 39, number 3. Page 39, number 3. Whoa, keep those open. Keep that review open. Keep that review open. You're going to have to go back to it. Because I believe if you keep scrolling on the review, I put this question there. I know it's in your packet. I don't care where you do it. You can do it on your Chromebook or in your packet. Julie, go ahead. Sophia.
What's the third theorem?
The sum of 2 sides greater than the third. Okay. So if I give you sides of a triangle are 12, 8, and 15, will that form a triangle? Okay, that's what I'm talking about. And in this case, it would form a triangle. Okay, because if you add up any 2 of those sides, it'll always be greater than the third side. Or, because I didn't want to say this yet because we're going to do a problem coming up, but if I tell you one side is 12 and one side's 8, you can write what the third side could possibly be. Okay, we're going to do that in a minute. So that's what I mean by the third theorem. All right, everyone ready here for number 3? Again, you can do it on your Chromebook because I put it as part of the review if you keep scrolling down, or you can do it right in your packet. We are not going to be able to put the segments in order until you find all the angle measures. So why don't we start there first? We applied this theorem the day before Thanksgiving break. Just so we're all on the same page. Here we go. Sully, what'd you find for those angle measures?
90 for angle MLO.
Is that what the right angle means?
Yeah.
Thank you. How about the missing ones?
38
Yeah.
and 43.
Okay, there you go. 38, 43. Got it. All right, we're ready to rank them now. I want this entire diagram ranked from shortest to longest. A reminder to use our little smallest side across from the smallest angle. This only works when you're working in a single triangle. So I don't want you to go on this problem. 38 is the smallest angle, so LO will be the smallest side. 87 is the biggest angle, and NO will be the biggest side. You're going from one triangle to the next. If you're going to do that, you got to do it in the same triangle. And that's what I'm going to have you do is take each triangle for me right now and rank the sides from smallest to biggest. All right, so go ahead and do that right now because I don't want to just follow the order of the angles. And actually, I made a mistake. The biggest angle is 90. So that would make MO the biggest side, which it won't come out to be the biggest side. All right, I need some rankings here for you. Let's start with MLO, triangle MLO. First, give me the shortest side so we can get going. Riley, shortest side of MLO?
LO.
LO, followed by
ML.
ML, and then how about the biggest side?
MO.
MO. Perfect. Thank you very much. And then somebody with triangle MON, triangle MON. Fiona, how about the smallest side?
MO.
MO, yep. And then next?
MN.
MN, and then
ON.
ON. Perfect. All right, we ready to rank them? Let's start with the smallest side in the diagram. Well, the smallest side is either the smallest side from either of the two triangles. So is it going to be LO or MO? Guys, look at the rankings. This is why I have you rank them. There's no shot it could be one of those sides based on what you've written already. LO versus MO. There's no shot it can be one of those. No shot. And I'll tell you why if you can't see it, but what's your call? Smallest side out of both of those. What's your call? Smallest side out of both of those, Cam? It is LO. Here's why. It can't be MO because look over here. There's two more smaller than MO. There's two smaller sides than MO, so it can't be the smallest overall. It's got to be LO. All right, next up. Here's where I start to get nervous. Are you just going to automatically go to MO? Because it's the smallest side in the other one. Look at your rankings. Is there anything smaller than MO? Yeah, there is. What's the one you said was smaller than MO? Riley, you actually said this.
ML.
ML, yeah. So I can't put MO because ML's smaller than it. Now what? Now I can put MO. All right, I don't want to go to MN. Don't give me MN because you ranked MO smaller than it, right? So MO's gone. And now, here we go. One more time. With the two, Natalie, I have left. Which one's smaller, MN or ON? MN, yeah. That's why you put it that way. And then ON, biggest overall. So there's our rankings. And you will have to do that on Monday. I'm not just going to ask for the shortest or longest. You will have to rank them. What's up, Assad?
We haven't had one yet, but what if like the shared one is the middle one?
What are you trying to future prediction? What's going to happen on the test? If that is the well, I think and correct me if I'm wrong. What Assad is saying is, what if you can't tell which one's bigger or smaller based on your rankings? Is that what you're saying? I will have side links on there already, so you can determine that answer. Okay, that's what he's saying. What if I get to a point where it's like, and I don't have an example here for you, but what if I get to the point where it's like I'm not too sure based on the rankings which one's smaller or bigger? I'll have actual side links on there, so heads up on that one. Okay. Questions on 3. I am done working in the packet. To get the next couple problems, you can either A, continue on with the review on Classroom, or you can go to the actual textbook page. It's up to you. All right, but I'm going to start working out of the textbook with some questions. So this is number 5 on page 381 of your textbook. Again, I put it on the review. You keep scrolling, right? Everyone, can you see it on the review? You keep scrolling down after the topics. Everyone can see it. I put it in order for you guys to just so you didn't have to bring up any textbook pages. So if you want to do it right there in the review, you can. It's up to you guys where you want to do it. All right, now we got to talk vocab. This is going to be a wake-up call for some of you. You're like, oh my God, I remember all that vocab and I forgot all of it already. We're all on the same problem here. I got number 5, whether you're going to the textbook page 381 or you're just using my unit test review on Classroom. All right, first, is this a true or false statement? And I'm going to ask somebody. I don't need anybody to yell it out. To find the centroid, you find the angle. You can't find it? It's not on Classroom?
It's not in the test review.
Yeah, you have to scroll down.
The topics we were just on. If you go to the topics I just posted there, yeah, keep going down. That's where I posted it. All good now?
Yeah.
Okay. So to find the centroid, you have to find all angle bisectors. If you're going to tell me it's false, replace the underlined word with the correct word. That's the directions here. Okay? You guys good here? Goof Troop, you good? Ready to go? All right, so the first thing I need from somebody is this true or false. If I want to find the centroid, find the angle bisectors. Ooh, boy, yeah, it's been a while since we worked this vocab, huh? So true or false, centroid, find the angle bisectors. True or false? True, Gianna? That is false, yes. That is false. So now tell me what I need to find then to get to the centroid. Because it is not the angle bisectors. That would have been the in-center. I'm trying to find the centroid. So if you want to go to the centroid, you need to find the what instead, Fiona? That's orthocenter. That would be the orthocenter, the altitude. The medians, correct. Good. And hey, if you didn't know that, hey, that's fine. This is more of a wake-up call. Be like, oh my, I got to review those vocab words again. Make sure I can fill in the blanks. All right, 14. You can read through it, but bottom line is those three baseball players represent the vertices of that triangle. Okay, those three baseball players represent the vertices. There's a fourth player on the team that wants to come in, so he is the same distance away from all of the other three. Name the point where he has to stand. I don't want you to find where it is on the triangle. I just need you to name the point. Okay, name the point where this fourth player should stand, so he's the same distance away from the other three. Where should that fourth player stand? Where should they stand, Riley?
Circumcenter.
Yes. Why should they stand at the circumcenter? Because the circumcenter is equidistant from the vertices. Okay. If the players represented the sides of the triangle, he would stand at the in-center. Okay. Circumcenter is equidistant from the vertices. In-center, equidistant from the sides. All good? Okay. So a little, hey, I need to know my vocab wake-up call. Next one I'm going to go to is 28 and 29. I just talked to Sophia about this, and I didn't mention it before because I knew we were going to do it right now. If you have two sides of a triangle or 5 or 7, on the test, I'm going to ask you to write the possible lengths of the third side as an inequality. Okay, let's go, Cam. So my third side I'm going to call X has to be between, and how do you find it?
2 and 12.
Okay, how'd you get the 2?
7 minus 5.
Good. You subtract the 2 given sides, and how'd you get the 12? You added them and got 12. Couple things, because I see this every year. Make sure the inequality symbols are going in the same direction. All right, sometimes I get one of these bad boys from a student. All right, that's cute. All right, nope, they're all going that way. And also a reminder about the homework problem I warned you about the other day. What if that's x minus 2? And I asked for possible values of x. I don't want 2 and 12. What do you got to do with that 2? Add 2 to both sides so you get x by itself. Okay? I'm looking for possible values of x, not x minus 2. Julia, question, go ahead.
If you were to use like greater than or equal to, wouldn't it be like
That would be
11.9 and like
not even, because now you're missing like 11.99.
okay.
Okay, yep. That's why it's safe not to go with the or equal to, because you're always going to be missing something. Okay. Good. All right. What if my sides are 10.5 and 4? 10.5 and 4 here. Fiona, what's it between then?
6.5 and 14.5.
Yeah. Good work. Okay, that's using the our licorice group theorem there. Sum of 2 sides greater than the third. How we feeling? Good? Glad I'm doing the review this way. Big wake-up call. Ooh, buckle up now. Buckle up for this one. Woo! Page 385, or keep scrolling down. All right, H is the in-center. So don't even start sniffing numbers 10 through 13. Don't even sniff them. Don't even look at them. H is the in-center. Mark your diagram up as much as possible. With what? Let's talk. In-center. Throw anything at me right now. What do you know about the in-center other than it starts with the letter I? Throw something at us here, Julia.
They're angle bisectors.
That's where the angle bisectors intersect. Perfect. So on my diagram, I should have arc marks flying around. Congruent, congruent. Angle C is getting bisected. 2 arc marks. Angle A is getting bisected. 3 arc marks. Ooh, I need more markings. What's the fact about the in-center? Fact about the in-center. Ooh, do we remember the fact, Natalie? Same distance from the side. So everyone look right now. You should be putting hash marks on 3 of these segments. If H is equidistant from the sides, which 3 segments in this diagram must be congruent? Maddie, what do you got?
FH, DH, and GH.
Good. FH, DH, GH. We have not even looked at the problem yet. And look at all the info we know now. Know your vocab. All right, let's do this. DH. Let's find DH. Well, Maddie just told us that DH is the same as HG, but I don't know that. The 11 goes to HB, by the way. All right, if anybody's wondering, 11 is the length of HB. All right, find DH. It's the same as GH, but I don't know that. And DH is the same as FH, but I don't know that. Or do I? Whatever FH is, it's going to be my answer to DH. Is there any way I could find FH? What do you got there, Ryan? Whoa, whoa! Some big words there. Don't I need a right triangle to do Pythagorean theorem? Yep. And I need 2 sides, which I do.
You have the hypotenuse and leg.
I know. I'm teaching. Thank you. Guys trying to show off here. Yes. Good job, Ryan. Thank you. You find FH, we found DH. Go ahead, Ryan. Now you can show off a little bit. What's the 24, a leg or a hypotenuse?
Leg.
Good. So that's got to go in for either A or B. And how about the 25?
It's the hypotenuse.
Okay, so that's got to go in for C. I believe this comes out to be a whole number, which I'll ask for someone in a second. Typing away. Jalen, what's that looking like when you have it? Seven. Yep. So if FH is 7, so is DH. Everybody good there? DH is 7. And so is HG, I guess, if we need that down the road. All good on that one. All right, everyone ready for 11 now. Find the length of BD. Find the length of BD. Look where BD is. AB is not getting bisected, so it's not like I can take half of anything there. Ooh. 7. Looking for DB. What's up, Sully?
Just do Pythagoras.
Again! Do I have another right triangle here? Yeah. And do I know 2 sides of this right triangle? The 7 we just found and the 11 that was given. All right, Sully, where's the 7? Leg or hypotenuse?
Leg,
What about the 11?
hypotenuse.
All right, so we're solving for another leg again. When you find this one, because I know it's not a whole number, can you just leave it in simplest radical form for me? Simplest form. What'd you think of that, Max, huh? Not bad? No? Clean the nose out down the hall, right? You got something for me? What? What?
No.
Yeah, exactly. When you have a thought, forget it.
No, I was just confused.
With what?
I messed up, but I see it now.
Great talk. I'm never going to be able to get that 10 seconds back in my life again.
I thought the b squared was
You're still doing it.
squared.
You're still doing it. Talking, breathing. You're still doing it.
So I didn't think 25 was squared. I thought it was c squared. But like now I understand it.
You want to just keep going, keep
No,
talking,
I'm
or are you
good,
done?
I'm good.
You're done? Okay.
Yeah, I get it now.
Okay, I'm glad to hear that. I don't know how I was going to sleep this weekend. Natalie, did you find that other leg?
Alright. The answer is 32 degrees.
32 degrees.
Oh wait, no, that's for the 12.
Yeah, relax. Stop.
Six.
Again, there's a bunch of show-offs in here today.
6 radicals.
6 radical 2. Let's look good, everyone. 6 radical 2. Okay, my diagram's getting a little messy. Sorry. All right, next one. HAC. HAC. Everyone see that angle? HAC. A little help before we get there. Shoo, Maddie, here you go. I'm sure Natalie can help you. She wants to show off here today. Down here, there's 28. What's the one next to it, Maddie? 28 as well. Good. Keep going. If that's 30, the one next to it? 30. So you do know the entire angle C and entire angle B, what they add up to. What about when I introduce angle A? What do all three of them add up to? Okay, so can you do me a favor? Let me know what angle A has to be then before I do anything.
$64.
64, good. And define half of it. What are you going to do with 64? All right, go ahead. 32 degrees. Yep. There it is. All good? And then one more here. I got to clean this thing up here. Wow. Let me just put this back here now. Okay, last one here for me. Gianna, back to you. We're trying to find angle DHG, the entire angle. So let me go to this triangle right here because I got a 30 and a 90. How many degrees left for the final angle?
58. Wait, no.
I got 30 here. I got 90. And then I want to find this remaining angle. 60. Good. So that's got to be 60.
Also 120.
And then the other one too has to be 60 because I had 30 and 90. So yes, $1.20. $1.20. Wow. It's intense. It's intense. And I haven't got to the last one yet. Oh, I love this last one. Little game we're going to play. I'm going to give you 3 angles. You tell me which one's the biggest one out of the 3. And you're not going to do, because it looks like it. Then you can leave the room. All right, 1, 5, 6. Out of 1, 5, and 6, which one is the biggest one? 1, 5, and 6. And you better back yourself up, other than it looks bigger. This is using one of our theorems before Thanksgiving. 1, 5, 6. Think you got something in your mind? Ho ho ho, ho ho. Everyone can just guess probably right because it looks like it, but you got to tell me why here. Cam, which one?
1.
Oh, it is 1. It is. And not because it looks like it. Any thoughts, Cam, why 1 is bigger than 5 and 6? What do you mean alternate? I don't think you mean alternate. I think you mean another word. There you go. Look, everybody see angle 1 is exterior. Hey, angle 1's exterior. 6 is the remote interior, so it's got to be bigger than that. Now look, 5 is not a remote interior, but it makes up one of the remote interiors, so 1's got to be bigger than, if 1 is bigger than the whole thing, 1's got to be bigger than the part. Make sense what we used on that one? Exterior bigger than any of the remote interiors. Next up, now it gets more challenging. Buckle up, 9, 8, 3. 9, 8, and 3. Which one is the bigger of the 3? 9, 8, and 3. Think you got something here? Come on. They just get tougher as we move on. Assad, what's good? 9, 8, or 3? 8 is correct. Let's discuss why it's 8. Let me first start why it's got to be bigger than 3. Here's 8. Everyone see its exterior? Here would be the remote interior. So if it's bigger than the whole, it's bigger than the part. So that's why it's bigger than 3. So why is 8 bigger than 9 now? Oh. How many degrees is angle 9?
90.
It's right next to a right angle, so that's got to be a right angle. Everyone with me so far? What's angle 7 have to be?
90.
90. Does everybody agree in this triangle right here? Angle 8 is exterior, and it's bigger than 7, which is 90 degrees. So angle 8 is bigger than any 90-degree angle, including angle 9. So that's why it's 8. And then my final one for you guys here today, 2, 3, 4. 2, 3, 4.
Oh my, wait, they're all inside. How do I do this one?
Think about it. Has nothing to do with exterior angles. I'll let you know that. Nothing to do with exterior angles, because there are none. They're all in the same triangle. 2, 3, 4. Which one's the biggest one? Come on, you can do this. You got it. Cam? 4. Cam, how many degrees are in angle 4? 90. And is there, since all of them add up to 180, is there any shot 2 or 3 is going to be bigger than 90? Nope, because that means it would go on over 180 if one of them were. All right, so good work. Last thing I need to show you. Can you go back to Classroom for me and open up the unit test extra review I've posted? I just want to show you what's in that in case you want to get more review this weekend. Unit test extra review. You have partitions. If anybody wants to get more practice with partitions, anybody wants to get more practice with our 3 inequality theorems, and also if anybody wants to get practice with our vocab. Okay, the vocabulary answer key is right there as well. So you have everything in your packet, and then if you want to get more particular, you got the extra review up on Classroom. There is no Delta Math review here. Okay, no Delta Math review. All good? I'll be after school today if you guys need anything. So you guys can choose where you want to go right now.